Hi, in this video I'm going to talk to you about operational amplifiers used as comparators. Now an operational amplifier has very high open loop gain. Alright, so this A over here, as you can see, is very high when we configure it in open loop. When we say open loop, there is no feedback from the output to any of the input terminals. Okay, so you can refer back to my other videos where I talk about the inverting and non-inverting configurations. The links are up above. Now, in an open loop configuration, basically you can connect the op amp. Okay, so I have that plus and negative. All right, so I can say that this plus goes to V in, all right, and this negative can go to some Vref, some reference. Okay, and then I have the output over here. So how does the op amp behave in a comparator configuration? So basically the rules are very simple. When V in is greater than Vref, we say that the output is equals to plus Vset. Now what is plus Vset? Plus Vset is roughly, okay, approximately around 1 volt less, okay, less than your plus VCC, okay, approximately around that value. Okay, now so what is plus VCC? It depends on how you have physically connected the chip in your circuit. Now op amps can be operated in both single supply mode or dual supply mode. In dual supply mode, you have plus VCC and negative VCC. In single supply mode, you have plus VCC and ground. Alright, so the case where V in is lesser than Vref, you have two possible options. Your V out can be equals to negative Vset. Okay, this is in your dual supply configuration, or your V out can be equals to ground. Okay, this is in your single supply configuration. Okay, so again, plus Vset and negative Vset is around 1 volt lesser than your plus minus VCC. Okay, put a minus here, so it's 1 volt lesser than your plus minus VCC for both your positive and your negative Vset. Okay, so where do I use this comparator? Whenever I want to generate an output by just knowing whether the input signal has gone above, okay, or below some threshold. All right, so for example, okay, I can if I say that I want to have I have a sensor, okay, let's say I have a temperature sensor over here, okay, and the output of the temperature sensor is giving me values from maybe 0 volts all the way to 5 volts. All right, and this corresponds to temperatures maybe from 25 degrees Celsius all the way to 50 degrees Celsius. Okay, so I'm just giving an example, and let's assume that I'm interested to know whenever the temperature goes above 40 degrees Celsius. All right, and that 40 degrees Celsius corresponds to maybe a voltage of 4 volts. Okay, now what I can do is I can connect up my operational amplifier, okay, where the positive is my temperature sensor module signal, and my negative in this case can be connected to a reference voltage which is equals to 4 volts. Okay, so my temperature sensor is going to give me some analog reading, analog voltage. Okay, it can go up and down, but whenever it goes above 4 volts, my output here, V out, will become take a value of positive Vset. Okay, if not, it will go to either negative Vset or ground. Okay, so in this example here, you can see that whenever, okay, I have a situation where this input signal goes above 4 volts, my output will go high. So if I were to draw the output signal, okay, it will look something like this, where normally it will be a low, okay, and at this point of time it will go high, okay, and then again it will go low. Okay, so something like that. So this is how you can actually use a comparator in a circuit to sort of detect events like this, where it goes above or below some threshold value. All right, so thank you for watching. All right, and please do check out my other videos where I talk about the inverting and non-inverting configuration of the op-amp. Thank you. Bye.